Have you ever wondered why cars use petrol, diesel, or batteries, but never nuclear power? It's a fair question. Nuclear energy is one of the most powerful energy sources we have. It runs entire cities, keeps submarines underwater for decades, and powers massive ships without refueling for years. So if nuclear power works so well in those places, why was it never used in normal cars? The answer isn't that it's impossible. It's that once you look closely, the idea creates more problems than it solves. At first glance, nuclear power sounds perfect for transportation. A very small amount of nuclear fuel can release an enormous amount of energy. Compared to petrol or batteries, it is far more energy dense. That's why nuclear reactors are used where long-term, reliable power really matters, such as in submarines and aircraft carriers. Because of this, engineers once believed nuclear energy could also power cars. This idea goes back to the 1950s. During that period, there was a lot of optimism around nuclear technology. Some car manufacturers genuinely believed nuclear power would be used in everyday vehicles. Ford even introduced a concept car called the Ford Nucleon, which was designed around a small nuclear reactor instead of a traditional engine. Although it never reached production, it showed that nuclear cars were taken seriously. So what stopped them? The biggest issue is radiation. Nuclear reactors naturally produce radiation, which is why power plants use thick layers of concrete and steel to protect people and the environment. That protection is extremely heavy. Most of a nuclear power plant size comes from safety shielding, not the reactor itself. When you try to scale that down for a car, the problem becomes clear. Either the shielding is too heavy for a vehicle, or it's reduced to the point where it no longer offers enough protection. There is no practical way to make a small nuclear reactor safe inside a normal car. Cars are involved in accidents every day, from minor collisions to serious crashes. A nuclear-powered car in a major accident would create risks far beyond a normal vehicle. Damage to the reactor could release radioactive material into the surrounding area. Instead of a standard road accident, authorities would be dealing with evacuations, specialized emergency teams, and long-term cleanup. That level of risk is unacceptable for something as common as personal transportation. There's also the problem of maintenance and security. Nuclear systems require constant monitoring and highly trained specialists. They are not something that can be serviced at regular garages. On top of that, nuclear material is tightly controlled worldwide. Allowing millions of nuclear-powered cars on public roads would raise serious security concerns. Because of these challenges, innovation moved in a different direction. Electric cars are not perfect, but their risks are much easier to manage. Battery failures are dangerous, but they don't cause long-term environmental contamination. Electric vehicles are simpler to regulate, easier to maintain, and far more acceptable to the public. That's why they became the future of everyday transportation. So why don't cars run on nuclear power? It's not because the technology doesn't exist. It's because nuclear energy is too complex, too risky, and too difficult to manage for daily road use. For personal vehicles, safety and practicality matter more than raw power. And that's why the world chose electric cars instead of nuclear ones.